Welcome back. This is the Death's Doorstep Devlog, Part 5. Since my last video, I've been spending a lot of time working on improving the hit effects I've been using in my game. After reworking a bunch of the hit animations, I realized that the combat system that I implemented didn't have as much punch as I would like. So I've been focusing on improving that, namely adding a little bit of bullet time hits to the attack. You can tell that the game slows down a little bit when you actually land attacks now, which it was not doing before. I might have been doing a freeze frame, I actually don't remember off the top of my head, but now it actually does like a full slow-mo that I can tweak and adjust to my liking. I might actually increase the amount of slowdown. I'm playing around with the idea of introducing a Arkham style combo system where if you land an attack and you hit the attack right based off of it, you can do a follow-up attack as well. I also added a little bit of screen shake on hit, which you can hopefully see as I'm landing these few attacks. I also just did a little bit of a deep dive on hit particles and how I want my hit particles to look, how to make hit particles look good, because I wasn't a huge fan of the way I had implemented it before. So now I've created my own little animation for the explosion of goo that comes out of the jellyfish there. So something I'm a little bit more happy with now at this point. I still have to add damage to the main character. If you look here, I can just walk through the enemy. I don't take any damage. I think that's the next big thing on my list to do. I'm still working on improving the combat system. I have some ideas that I'm definitely going with at this point, but there's still a lot more work to be done there. So I'll walk you through some of the things that I've done. To start off, let's actually give you a little bit of a slow-mo as to what's going on, because doing hit effects in real time, it's really easy to miss all of the fine details. I noticed this a lot when trying to improve my own by learning off of other examples. Looking at hit effects in slow-mo really helps to get an idea and get a sense of what's going on. So I'm going to give you a little slow-mo of what's going on with mine here. So let's paste this out a little bit. Ah, crap. I screwed it up. Alright, here, help me here. Alright, hopefully that works. So let's give you a nice little slow-mo of what's going on. So you can see flash white for the enemy. The initial hit effect is very dark to contrast the hit that's going on. And then there's a few seconds of freeze frame there. In that time, not a whole lot happens. The animation continues, and then the actual impact ends, where the contrast disappears, it actually bursts away, the enemy takes a little bit of a squish going on and starts getting knocked away, and the player resumes the hit animation. So that's basically the gist of it in QuickTime. And then on top of that there was screen shake, which you couldn't really tell because I was zoomed in there. I can show you again real quick. So if I zoom out a little bit more, it'll be a bit easier to tell. It doesn't happen until the freeze frame's over, but there you can see the camera shake is bouncing back and forth. Just a little bit of a camera shake. I didn't want to make it too much because the user's not taking damage or anything like that. They're hitting an enemy. I just want to feel impactful, not necessarily like something bad just happened. So I'm gonna walk you through all the little bits that I did to give it that feel that I liked, as well as some of the coding I had to do to get the slowdowns in place, which was probably the most amount of work to get this all working. So let's actually jump into the code of how this works. So if you've seen my previous videos, you know that I have a state model and all of the different attack animations are broken into different states. So this would be the first whip animation, whip 1. The actual collisions are handled in a separate service, which is here, whip collisions. This is where I set up the listener, and then when the collisions actually happen, it'll happen in this class here. And this is the one I'm looking for, jellyfish enter. So on a collision with the jellyfish, damage it, toss it into its own hurt state, and then play the hit effect based on the direction that I'm currently facing. So I'll show you real quick here, but there's actually two different effects on the jellyfish object. So if I hit him from this side, the goo spits out in my direction, and likewise if I hit him from this side. So those are two different particle effects on it, and then if I jump, it'll actually spray both of them, just to show that I'm landing on top. So we'll do that before going into the slow-mo. Here's where the slow-mo actually happens. So I have this helper method called begin impact, where I pass the collision data, and a method to be run after the slow-mo ends. So let's jump over to begin impact, which is down here. So here we got my so these are my async helpers. I'll give you more in-depth look at those in a little bit, but all you really need to know is that this is starting a coroutine with ease in, easing. This is just a reference to the coroutine that I'm storing. So if I go to slow-mo, you can see it's just a coroutine variable. The reason I pass it in as a ref is so that I can make sure to clean any existing coroutines that are using this variable first before starting to reuse it. This is a little bit part of the cleanup that I did with my async helper, which I will go more in depth to with that in a little bit. It takes about 0.05 of a second to complete before going back to full speed. I also added basically a way for me to pick the type of time that I want for the async helper. So I have real time here, so I want it to happen in real time as opposed to scaled time. And then this is where it actually, during each step of this asynchronous loop, set the value. This is the val between these two numbers that I'm going to be lerping, and set the val based on what we're currently at. And then after it's all done, fire a new event, whip collisions hit. This is for the actual whip classes to pick up on. So each one has their own way to deal with this. So whip collision hit. In this case, it'll enter its ending animation. It will set its speed based on the current direction it's facing, just to bounce away from the enemy a little bit, as well as add a little bit of horizontal squish to the enemy. So that's where that happens. If I pass an on-complete, which I did, I'm always going to be passing an on-complete here. This was just for some other test objects that I don't currently have this set up for yet. So call the on-complete method, which you can see was defined up here. I'll dive into that in a little bit. And then do the camera shake. This is where that happens. So if we're doing the up whip animation, then do the vertical whip, or do the vertical camera shake, or do the horizontal one. So I'll show you how that one works real quick. So I actually have another service on the camera object called screen shake, and that has two methods itself. So you can see it's just a standard service. It has a view object attached to it. The view object is actually a child object, so I can shift it around while the actual positioning of the camera happens in the parent object, which is really nice because it means that I can line up the camera where it's supposed to be, but at the same time still shake internally while maintaining that position. So here is the horizontal light. You can see I'm just bouncing from a 0.01. Again, I'm using this async class, bouncing from a 0.01 to a 0, passing in that shake coroutine, the amount of time I want to shake for, and then on each step I'm just shifting the local X back and forth until it reaches to 0 again. And I'm flipping it back between a negative position and a positive position just to give it an extra oomph. And the same thing with the vertical, except I'm using local Y instead of local X. So I actually realized I forgot to show you what this line is actually doing. So this line here, game.tempo, is basically just setting the game time. I did mention that, but I didn't actually show you the service that I'm using to handle that case. It's actually really simple. It's just simply take a timescale variable and set the time.timescale as well as time.fixed tilt timescale based on that number, and then that will set the slow-mo for the game. Basically, I'm not going to go too in depth with how Unity does it, but I had to rework a little bit because I actually hadn't set up my engine to use the timescale as well as I should have, but now it does because I really wanted to have this. So this simple little method does all of the hard work. Well, Unity actually does all of the hard work. This ties into how Unity does all of the hard work. So alright, so let's jump back to that onComplete method that we looked at above. So once the impact is all done, once the slow-mo has finished, then at that point, make the enemy bounce away. And now we can move on to how my async service works. So I did a decent amount of rework here. I already had it before, pretty much the same, but this is kind of just more usability things, like passing a ref to a coroutine. Originally, I was just returning a reference to a coroutine from the different easing methods, as you can see. These used to all return coroutine objects, and then I would have to call halt, which ends the current coroutine and then starts a new coroutine. I changed that to instead use a ref, so then I can just pass in the coroutine, at which point it can automatically halt the previous coroutine and start the new one. In addition, I also added the option of time. I had fixed time and scale time options before, but I had no option for real time. So I created this enum up here time type, which you can see it uses the draw time, the physics time, or real time. Physics I actually haven't found a use case for yet, though. I gave myself the option for it in the future in case I want it. Real time is really convenient, as well as this equates to scale time and unscaled time, which is what Unity tends to call them. This is just kind of the nomenclature I've been using within my own game. So a lot of what this service does is, as you can see, just starting and stopping coroutines. So it gives me a really easy way to set coroutines with certain easing, and as well it makes it really easy for me to read within my code. But you can see the end result is actually something pretty readable. It's just one giant chunk of code. So that's all I really have to show off this week. There was a lot of, for me, deep diving as to how I wanted to handle better particles. I'm happy with the result that I ended up with, though there's still a few more tweaks I want to make to the combat system. The actual method of how I do my collision impact, I think I kind of picked up the way that I like to do it in my personal preference, and I'm just going to keep going with that. I might make a little bit improvements here and there, but I got a much better idea of how I want to do it in the long run, even for new enemy types. If you want me to go more in depth with anything that I mentioned in this video, specifically around time scaling, easing, aka the async service, I'm more than willing to. Just feel free to ask in the comments. For now, I'm just going to leave that there for this week. I was a little bit delayed on this video, hoping the next video I won't get delayed on. I had a few busy weeks with the baby at home, so just a little bit slower than usual. Either way, till next time, take it easy.